Okay, so a typical motion question usually has to do with when is something going left, right, or stationary. This is something we've been working on in class. And when we ask about left, right, and stationary, usually I have you try and refer back to velocity. Velocity is really the key. If you know what's going on with velocity, you know if an object is going left, right, or stationary. So if velocity is positive, if it's greater than 0, it's a positive number, then we know the object's moving to the right. Or if it's an object that's going up in the air and down in the air, up and down, then we know the object's moving up. So positive velocity means a right motion or an up motion. Negative velocity, when velocity is less than 0, refers to an object going to the left or going down. And then the only other possible case is what if you get velocity equal to 0, and if velocity is actually equal to 0, then we know the object is stationary. Which totally makes sense when you see this, like these three little pieces of information, it seems very logical. But when you get into doing these problems, lots of people make lots of mistakes. And that's because you have to be so careful. And a lot of times, this is what you get. You get some sort of a graph. And so if you want to pause the video and copy this down, you can. Here's a graph, and I'm going to ask you about when is this object moving to the left, when is it moving to the right, and when is it stationary. So I'm going to have 3 questions for you here, left, right, and stationary. But you're not going to be able to answer this question until you know what kind of graph this is. Are we looking at the position of the object or the velocity of the object? So let's say, for this sake, we're looking at a position graph. And so that means this object is moving in minutes over here, and the y-axis is the position of the moving object. So if I told you the y-axis was miles, and I said, where is the object after 3 minutes of traveling? You'd say 3 minutes of traveling, it is 0 miles. It's at the 0 marker here. It's 0 miles away. Okay, after 3 minutes, it's standing at the starting point. After 4 minutes, you would say it's negative 2 miles back. It must have went 2 miles backwards. If I asked you at the 0 minute marker here, where is the object, you'd say it's standing 4 miles away. So that's kind of how you read this graph. Well, we want to know not where is it standing. We don't care about its position as much as we want to know when's it going left, when's it going right, and when's it going stationary. So left, right, and stationary are determined by velocity. When is the velocity positive? When is the velocity negative? That kind of a thing. So left is when velocity is less than 0. And if I look at my graph here, this is not a velocity graph. This is a position graph. If I want velocity, I have to derive position, x of t. I have to find x prime of t. And currently, this is the x of t graph. So, one derivative up means I need to calculate some slope values. I'm going to look at this graph and notice that the first line segment here has a negative slope. So, velocity must be less than 0, negative, on this first line segment here. So we got a negative velocity kind of going on. And I think so that my graph isn't totally messy here, what I'm going to do is just write a little negative sign for the slope here. Then I have a slope that's totally flat for this 2 to 3 section. For 2 to 3 minutes, the object has a slope of 0. Then I've got more negative slope here, so I'm thinking I'll just put a little negative sign. And then for this last portion that's going out to infinity, I've got positive slope. So positive slope. So the question was, when is this object moving to the left? When is the velocity negative? And I'm seeing from 1 to 2, this portion right here, and from 3 to 4, this portion right here. So 2 sections. So that's how I'm going to write my answer. I'm going to say that the left moving object goes left from 0 to 2, and I'm also going to say from 3 to 4. Alright, so the next question, when's the object moving to the right? Well, that's going to be when is velocity greater than 0, positive, and we really only had positive velocity on this last portion here. So we're going to say that the positive velocity is occurring from 4 minutes to infinity. It never stops according to the arrow. 4 to infinity. And then when is the object stationary? Well, it's going to be stationary when velocity is equal to 0. And on my graph here, velocity equals 0 from 2 to 3 minutes. So we're going to say 2 to 3 is our answer for stationary. And we're done. Now, that's how you read the graph if it's a position graph. You use the slope to get these answers. But a lot of people get caught up and think, okay, I just always calculate the slope. If it's positive slope, it's going to the right. Well, not necessarily. What if I gave you the same graph again, but I told you, just kidding, this is not a graph of position. This is a graph of velocity. This is a velocity graph. This is v of t when I'm looking at it. That means over here on the y-axis, all these numbers are not representing the position of the particle. They're representing how fast the particle is moving. So maybe these are miles, maybe these are miles per hour over here. So like the object, when I'm studying the object here, the object is moving 4 miles per hour at the 0 minute marker here. That's how fast it's going. Or like the object is going at 5 minutes. How fast is the object moving? It's at 0, so it's going 0 miles per hour. It's not moving at all. Or at 4 minutes here, how fast is the object going? Well, it's going 2 miles per hour, but it's -2. -2 velocity. So when I start asking those questions, when's the object moving to the left? When's the object moving to the right? And when is it stationary? Now I got to look at this graph and answer it a little bit differently. Don't use the slope. You'll be wrong if you use the slope. Now if I said when's it going to the left, you'd say, well, it goes to the left when our velocity is less than 0. And this is a graph of velocity. So when is velocity less than 0? Right here, down below, when it's in the negative. So from 3 to 5 minutes, we have negative velocity. So the answer is going to be from 3 to 5 minutes. Notice how that's different than last time. We said it was going to the left from 0 to 2 and 3 to 4. We did it all based on slope. Now we're looking at the location of the graph. It's down in the negative from 3 to 5 minutes. So when is the object going to the right? Well, that's when velocity is greater than 0. Positive velocity is occurring on this graph in the first 2 minutes here. This is all positive velocity because it's located up above. So I'm going to say from 0 to 2 minutes. I'm also seeing positive velocity right here after the 5 minute marker, from 5 to infinity. So I'm going to say from 5 to infinity minutes. When is it stationary? Well, that's when velocity equals 0, 0 miles per hour. And I'm seeing 0 miles per hour here from 2 to 3 minutes because it's at the 0 marker here. I'm also seeing that at 5 minutes, it's equal to 0 miles per hour. So I'm seeing a couple of answers. I'm seeing from 2 to 3 minutes, it's stationary, but also at time equals 5 minutes for just a moment in time there. And there's my answer. So I guess the message in this video is when you look at a graph and you're answering these left-right stationary problems, you need to pay very close attention to what type of graph is it. Is it a velocity graph or is it a position graph? Because that changes the way you answer your question.